can use AI to solve an equation in seconds. They can ask for steps, explanations, even variations, and turn them in without showing a lick of original thinking. But here's what AI cannot do: it cannot document the journey of learning, it cannot capture confusion, curiosity, and growth over time, and it certainly cannot reflect with self awareness or personalized meaning. And that's where portfolios come in. In this episode, we're going to walk you through how to create concept based math portfolios that are cheat resistant, growth centered, and alternatives to traditional assessments. These portfolios turn students into reflective, connected, and empowered mathematical thinkers. Let's jump in. You want to reframe assessment as a collection, not a snapshot. Tell the students you are not turning in one perfect answer. You're building evidence of your thinking over time. Each portfolio is made up of artifacts such as initial explorations, AI prompting logs, error corrections, real world applications, and self reflections. These artifacts work together to show not just what a student knows, but how they're growing. You should start each unit with a guiding question. For example, how do patterns help us model change? How does geometry influence design in our everyday world? Why does precision matter in measurements and scale? This question anchors their portfolio. Every entry must connect back to it. Here you want to scaffold portfolio entries across stages of learning. The beginning of a unit, you can ask, what do you already understand about this concept? What do you wonder? Use AI to explore multiple definitions and ask them which one resonates and why. Midway through the unit, ask, how has your understanding changed? What problem challenged you the most? What's a real world example of this concept? Use AI to help you generate one. At the end of the unit, have them summarize their learning in a creative way. An example of that can be where they create an analogy, a diagram, a teaching script, and ask them, what mistakes helped you grow? What prompt did you ask AI that helped you think differently? Now you're documenting growth, not perfection. We want to make AI prompting part of the process, not a shortcut. Here you can require students to record the prompts they gave to AI, screenshot or summarize the AI responses, reflect on which one helped and which ones confused them. They can compare the AI's explanation to their own thinking. This turns AI into a thinking tool and not a cheating tool. We can use story and synthesis to deepen conceptual understanding. You can ask students, how would you teach this concept to younger students? Or have them tell a story or create a scenario where this math shows up in real life. You can have them use AI to help generate the story, but you add the context and the analysis. Now we're blending mathematical reasoning with creativity and communication. In this process, we must require connections to prior knowledge and future learning. Sample prompts can include, what math ideas from earlier this year help you understand this topic? What do you think this concept prepares you for next? You can have them use AI to generate an example of how this concept is used in a job or industry. Analyze it for accuracy. This is going to build coherence. Students are no longer studying isolated skills, they're connecting a mathematical web. In this step, we want to include peer feedback and revisions. We want to have students trade artifacts, use a feedback protocol such as, I noticed this, or I wonder about this, or I suggest this, that, and the other. And you're going to have them revise their entries and explain their thinking. And this is going to build ownership, collaboration, and metacognitive awareness. Here, we always have to build a rubric to help students reflect on what matters. And here you see a sample of a scoring guide where 25% is going towards conceptual clarity and explanation, 25% is going to thoughtful AI interaction such as prompting, critiquing, application, 25% is going to go to reflection, growth, and connections over time, and 25% will go to accuracy and application of mathematical procedures. So you have to notice here, only a quarter is about getting it right. The rest is about thinking, which is a real game changer. And finally, we're going to celebrate mathematical thinking. We're going to make the final portfolio celebration public. You can end the unit with a portfolio walk, a digital math showcase, a gallery of student-centered math stories or real-world problems, and you're going to have students present. Here's how I used AI to learn, not to cheat, and how I got there. Now you're reinforcing that math is not just about speed or correctness, It's about development, curiosity, and depth. Stop cheating in math. Do not assign tasks that reward only answers. Assign work that requires thinking over time. Because AI can fake a worksheet, but it cannot fake growth. It cannot reflect on confusion. It cannot show the evolution of a student's mindset. Only the student can do that. And when you build that into your assignment, when the journey becomes the product, there's nothing for AI to take over. Because you've already made thinking the non negotiable. Let's build portfolios that reveal what matters. Let's make learning too personal to plagiarize. Let's redefine success in math, one artifact at a time.